Okay, so we are still on page 366. Problem number 3 and problem number 4 are just like problems number 1 and number 2. Number 3 is exactly like number 1 and number 2. You just need to add the two electrical sources together, and you're just trying to find the voltage, the combined voltage. On problem number 4, you have to take it a step further. You also have to find the combined phase shift. So problem 4, after you've done all the work like we did on number 1 and number 2, and you have found it in Cartesian form, not only do you have to find the magnitude, but you also have to find the angle for the phase shift. So just complete the change over to polar form. Okay, so on problem 2, we had stopped, and problem number 1, we had stopped after we found the magnitude. We took it from Cartesian form and we were changing it to polar form, but we stopped after we found the magnitude. We did not bother going to find the angle. Okay, but you're just going to keep going and find the angle as well. All right, if you have questions about that, send me an email. So moving on to problem 5. Problem 5 was the inspiration for your final exam. It talks about sunrise and sunset. So in the book, the textbook, it's written really different than in the digital version. So make sure you pay attention, use the digital version. Okay, it is given that the times of sunrise in London in hours after midnight can be modeled by the function f of t, okay, time, is equal to 2.14 sine of 0.0165 t plus 1.81, close parentheses, plus 5.97. Okay, and this is sunrise. And in a similar way, it says sunset, so f of t for sunset. Okay, that was the rise. For the set, it's going to be 2.19 sine of 0.0165 t minus 1.23 plus 18.0. So this is the time that the sun rises. This is the time that the sun sets. Now they want us to write a function that will model the length of daylight. The length of daylight. How much daylight is there going to be? Well, if I know that the sun is setting at, say, 6 o'clock at night, and it rose at 5 o'clock in the morning, and now it's setting at 5 o'clock in the evening. Well, what's the difference between those? Well, that's 12 hours in between. So there's going to be 12 hours of daylight. Okay, so all we have to do is take sunset, okay, the function for sunset, and subtract the function for sunrise. Because if we know the time that the sun is setting and we know at the time that the sun rose, all we got to do is subtract them from each other and we'll have the difference in between. Okay, and this is assuming that they don't restart counting at noon, which would be silly. So that this is on a 24-hour clock. All right, so that's all we got to do is we got to just subtract these. So I should have written it the other way. I should have written this one first and that one second, but that's okay. We just need to subtract them from each other. So I'm going to have... let's see, where's my notes? I'm going to make sure I don't mess up. So I'm going to subtract them from each other. I'm going to have this one minus this one. Okay, so if I subtract these, the only thing that I can combine right away, the only like terms I have right away are these two right here. Okay, I'm going to have these two right here. And then, because these two are not combining like terms. All right, so we can combine these. So if I subtract these, I have my handy dandy graphing calculator, which is now charged. Okay, so I've got 18 minus 5.97, and that gets me 12.03. So I know this part is going to end up being 12.03. And notice this is my vertical shift. Okay, this is my vertical shift on my function. So it's going to end up being 12.03. Does that number seem familiar? Those of you who've started your final exam? Oh, very interesting. All right. And then the rest of this, though, we kind of have a problem. We have different phase shifts here. Look, we have the same period, but we have different phase shifts. And of course, we have different amplitudes, but hey, this is just like the voltage problems we were just doing. If we can rewrite this and this in polar form, in cis form, then we can go ahead and change them to Cartesian form and add or subtract them, right? So that's what we're going to do. So this part I'm already done with. I'm going to keep that. Now these, I'm going to go ahead and write them in cis form. So I'm going to start with this one. I'm going to have 2.19 cis. Notice this one's negative, that one's positive, so I'm going to put negative 1.23. And then I'm going to be subtracting this one, 2.14 cis, and this one's positive 1.81. And then plus 12.03. That's just kind of an afterthought. I'm going to add that on at the end. All right, so that's how I set this up. This is how I take care of this. And then we just do it like we've been doing all of our other problems, where I'm going to write this out in with my sine and cosine, or sorry, cosine and sine, and multiply it out. You can also go ahead, you know what, since these aren't exact, we can go ahead and just change these to Cartesian form right on the graphing calculator, because we don't have to worry about this being an exact form. So I'm going to go ahead and enter this into my graphing calculator, 2.19. And remember, when I have cis, I have to enter it in Euler form. So I'm going to do second to get my e to the, and it's going to be negative 1.23 I. Okay, and then I'm going to minus 2.14. Actually, you know what? What do I want to do? I'm going to, I think, just to make it a little more clear, does it really matter? How many steps do I want to do this in? Let's go ahead and just keep going. I've already started down this slippery slope. Let's just keep going. Okay, so I'm going to minus 2.14 cis to the 1.81 I. Don't forget the i's. And I'm going to go ahead and add those together. I'll worry about the 12.03 later. And I get this. Actually, is that, we're trying to show that something equals something, aren't we? What am I trying to show? Is modeled by the function. Okay, so let's see what happens. All right, so I did this, and notice it gave it to me in Cartesian form. So it gave it to me in Cartesian form, so I could write that down, 1.24 if I'm using three significant figs, minus 4.14 I. Okay, but since I'm going ahead, I have it here in the calculator, let's go ahead and change it to polar form, because it wants the answer in polar form. So let's change that to polar form. So I'm going to take my answer, and I'm going to go math, complex, change it to polar form. Enter again. And there it is. I get 4.32. And see how it says e to the blah, blah, blah? I can change that to cis. And it's a negative. So cis negative 1.28. I'm using three significant figures. So this minus that gives me this. And I still have my plus 12.03. that I'm bringing down from there. Does that match what it has in the book? Almost, except it wants me to write it in sine form. Okay, so to change it back to the sine form, remember they both have the same period. This part right here, I'm going to put that back in. So when I change this back to sinusoidal form, 4.32 sine 0.0165 t minus 1.28, changing it back to that sinusoidal form, plus 12.03. So there it is. Okay, and I was able to do that pretty much all with my graphing calculator. Very cool. All right, B, hence, find an expression for the length of daylight on day T and the length of the longest and shortest days according to the model. Okay, well, we already have our expression for daylight. Here it is. This is my daylight, okay? And we want to, let's see, we want to find the longest and shortest days according to the model. All right, so this is a sine function, right? So if I were to graph this, it's going to have a phase shift, so it's not going to start here. So we'll just like, oh, and it's going to be moved up 12.03. So my principal axis that splits it, this is going to actually be my principal axis. This is going to be my 12.03, and my amplitude is going to take it up this amount, 4.32. So this is going to be 4.32. So the maximum daylight that I'm going to have is going to be 12.03, my principal axis, plus my amplitude. So the longest day is going to be these two added together. So sorry, my paper's showing through here. So my longest day is going to be 4.32 plus 12.03. And my shortest day is going to be 12.03 minus the amplitude, 4.32. So if we do that, did I do that on my scratch paper somewhere? Where's my scratch paper? Yeah. If we do that, we get for the longest day, we get 16.35. And for the shortest day, we get 7.71. Okay, so this should remind you of our final exam project for those of you who've already started it. All right, so now we need to find, well, when does this happen? What date do we get these longest and shortest days? So this is where I would actually want to put this into my graphing calculator. So I am going to put this in. Let me clear out everything I've got in here. I'm going to put in my sunlight function here into my graphing calculator. 4.32 sine 0.0165x minus 1.28, close parentheses, plus 12.03. Get the whole thing in there. I'm going to graph it. Oops, hold on a second. I got something in stat plot. Let me clear that out. Turning off my stat plot. There we go. Okay, and you can't see it very good. So let's do a zoom. Let's see, what is going to be my y-axis? I can think about my window here. My window for my y, I'm going to go ahead and put in -1. And for my maximum, I'm going to put in 20 because I know that my maximum number of hours is going to be 16.35. So that'll show up there. And then days, well, this is in a year, right? So I'm going to go from 365 days. Well, let's make it 375 days. Okay, let's make sure we can see all the days in there. All right, so let's go ahead and see what that looks like now. Whoa, look at that. That should look familiar again for those of you who've been working on your final exam. This is just like one of our final exam questions. Look, it's a sine wave. So when do I have my longest day, right? What date is that happening on? So I want to maximize this. So I'm going to go second. Can you see what I'm doing? Second, trace, and I want the maximum. And I'm going to go left bound and right bound, enter, enter. And it says that, if you can see this, it says y is 16.35, which is what I got by doing it by hand also. And that's my maximum number of hours. But when does that happen? On day 172. It says 172.77. Okay, so 172 on day 172. Day 172. So if I figure out what the actual date is, that would take me a little more work to figure out. But we could figure out what day that is. But I'm not gonna. It's in June. It's around June 20th. Okay, but you could figure that out exactly. But it's going to be on the 172nd day. And then when is it going to be at its lowest? It looks like it's lowest over here. So I'm going to do second trace again. And I want the minimum, and let's go ahead and see if we can find it. I might want to actually change my window a little bit so I can get both sides of it. Oh, look, it let me just scoot it over. That was nice of it. And it tells me that the minimum value is going to be 7.71, which again, I had figured out by hand. And it tells me that that's going to happen on day 363. Day 363. Well, that's kind of easy to figure out, 363, because there's 365 days in a year. So this is going to happen 2 days before the end of the year. So I know that that's going to be December 29th. That would be December 29th. So you could figure out the actual date, but just finding the day by using your graphing calculator is fine. And oh my gosh, that's it. Finally, the end of page 366. I feel like I've been working on this for hours. All right. Hope that helped. Good night.